So be sure you put your name on it. I do have one packet from third hour and several packets from fourth hour with no names. You can have those. I also like to put the date at the beginning of the packet because then I know how far to look, not 10. I know how far to look back in Google Classroom to see when we started this packet, right? So the videos that you are looking for will start on 11/18, and you can see that when you look at your packet in class. And then go ahead and write your hour. All right, so remember, if it's on my packet, it should be on yours. There's also going to be some independent work that we go through. The other reminder is the expectation that if you're absent, you need to still complete those pages in your packet because it's just meant to help you, right? It's trying to keep you on the same schedule as everyone else. If you fall behind, you have to work to get caught up. That's just kind of real world life, right? A ratio is a comparison. So in this first blank, we're writing the word comparison. Comparison of, and then we have two blanks. The first blank is the number 2, TWO, values. A ratio is a comparison of two values. So ratios can compare part to part to whole, or whole to part. So when we're looking at these, yes. Kind of. They're just written in reverse order, right? So if I said 2 bananas to 4 apples, this would be part to part, right? This would be part to part. If I said 4 apples to 6 pieces of fruit, that would be part to what? The whole. Good. And if I said 6 pieces of fruit to 2 bananas, that's where it's a little bit different. That would be whole to part. So that's why we can do it in both directions. The whole is the 6 pieces, right? And part of it is the banana. So it's we can change the order up a little bit. We have to know what we're talking about. All right, so we might see ratios written in a number of different ways. Sometimes it's always read A to B, but sometimes they use a colon between the two. Sometimes they write out the word to, so it literally says A to B. And sometimes we write ratios as a fraction. We would read it from top to bottom, A to B. All right, so looking over here on the left, we're going to write each ratio in 2 different ways. So I'm going to go ahead and draw a line through here because I have to write them in 2 different ways. Shaded squares to unshaded squares. So how many shaded squares do I have? How many shaded squares do I have? Yep, we have 10. Let's write this one this first way first. 10 to, how many unshaded squares do we have? 6. So I can write it like this, or I could write it as a fraction, right? 10 to 6. How about unshaded squares to total squares? We said we had how many unshaded squares? 6. To how many total squares were there? 16. Very good. So this was part to part. This is part to whole. And then we could write this as a fraction too, right? Total squares. So we said there were a total of 16 to unshaded squares. No, to shaded squares, sorry. So there were 10 shaded squares. So we can write this as a fraction too. So there's 2 different ways we can write it. We could also use the words, but that just seems like a lot of work to me. Unshaded squares. Again, 6 to shaded, 10. So you really have to just pay attention to what order they are in, right? All right. As you notice, we have a lot of even numbers going on here. So you might think, oh, that is like a fraction. We could simplify that. So just like fractions, ratios can be written in simplest form too, okay? So we have to find the greatest common factor of the numerator and the denominator. All right. All right, guys. So if we're finding the greatest common factor of 8 and 12, I would look down my 8s and I would look down my 12s and think, what can I divide 8 by? I can divide it by 2. I can divide it by 4. I can divide it by 8. 12s I could divide by 2. I could divide by 3. I could divide by 4. I could divide by 6 and 12. So what is the biggest number that I could divide both 8 and 12 by? 4. Good. So I can divide the 8 by the 4, and whatever I do to the top, I have to do to the bottom. Make sure you're writing it out twice. Notice this is not 8/12 divided by 4, right? So what is 8 divided by 4? 2. And what is 12 divided by 4? 3. Don't forget your fraction bar in the middle. Now there's no other number besides 1 that we could divide both 2 and 3 by, which means this is as simplified as it gets. All right. So first of all, we have to write this in simplest form in 2 different ways. So I think it's easiest sometimes, Amani, make sure you're focused, to write these as a fraction, 6 to 12. Okay, grab your stuff. If I'm thinking, 6th graders, if I'm thinking, what can I divide these 2 things by? You can take it with you if you don't think you're coming back, because you'll still be responsible for the pages. Or you can put it on that yellow folder. 6, very good. So if I divide the 6 by 6, we have what? What is 12 divided by 1? Thank you, it is. But what's 12 divided by 6? I asked the wrong question, good answer. 2, right? No, that was my bad, actually. All right, so that's it. This is in simplest form, so we just need to write it a different way in simplest form, which we could switch it like this. James, you've got catching up to do. Let's go. I'm sorry, but you can see parts of it. All right, guys, we're not going to get too far for this chatty today. 15/20ths. 15 to 20. What can I divide these by? They both end in a 0 or a 5, so we can divide them by. Well done. That's why we practice divisibility rules. 5 times what is 15? 5 times what is 20? This is as simplified as it gets, but it wants it 2 different ways, so we could write it as 3, 2, 4, right? All right, so that is page numero uno. Okay. Ratios, ratios, ratios. All right, page 2. I'm going to do these odds. I want you to do these evens. Are you ready? 20 to 4. What can I divide them both by? 4. 4 times what is 20? Wait, no. 4 times what is 4? So we're going to leave these in ratio form though, right? 5 to 1 or 5 to 1. All right, so let's look at 16 and 72. So I'm gonna look and see what I can divide them both by. 16 doesn't go into 72, but 8 does. There's a lot. What can I divide the 16 and the 72 by? 8. Eight times what is 16? 2. 8 times what is 72? 9. Very good. So we could write this as 2 to 9 as well. Remember, it wants us to write it and practice it in 2 different ways. All right, SJ, not helpful. Vowels to consonants in the word dictionary. How many vowels are in the word dictionary? 1, 2, 3, 4. Good. So I have 4 to how many? Oh, you're welcome. 1, 2, 3, 4, 5, 6. Well done. What can I divide 4 and 6 by? 2, because they're even. 2 times what is 4? 2 times what is 4? It's a division problem. 2. 2 times what is 6? 3. All right, and so I could write it like this as well, okay? Try number 8. I want to see what you get. Start by writing it down. 14 over 6. How can you simplify? Start by writing it down. sleeping. Stop your yapping. They're even. Start by dividing them by what if they're even? Yes. You can't divide them by 1. It won't change them. Sixth graders. 14 over 6. What did you simplify it to? 7 over what? 3. So we would read this as 7 to 3. Oops. This is a 3, sorry. Then you start by writing this down. Turn your voices off. Guys, I can go real fast and let you do these on your own, but I'm trying to have you try them before I make you do them completely on your own. So I need you to stop talking and work along with me. Look along here. I have these both right here. So what could I divide by? 3. So it becomes what? 6 over 5 or 6 to 5. We're not changing these to mixed numbers because they're ratios. They mean something. The 6 belongs to the necklaces. The 5 belongs to the bracelets, okay? All right, well, how many girls are here today? 2, 4, 6, 7. I make 8. So 8 to what? How many people total are here currently? 2, 4, 6, 8, 10, 12, 14. I'll make 15, and then we won't have to simplify. Even though I'm not a student, will count me. How's that? All right. Oh, guys, listen. Out of 75 students, 36 bring their lunch. What's the ratios of students who buy their lunch? So how many students buy their lunch?
86.
How many students buy their lunch? Read the problem. 36. So we have 36 to what? How many students bring their lunch? No. That's whole. So we have to say 75 minus 36, right? All right. What could I divide these both by? 3. Let's try 3. So this is 12, and then this would be one more group of 3. 12 to 13. For every 12 student who buys their lunch, 13 students bring their lunch, okay? Ariel worked 16 hours at the grocery store and 24 hours at the library. Write a ratio of the number of hours she worked at the library. How many hours did she work at the library? 24. To the total number of hours she worked. We have to add these together to find the total number of hours she worked. Good. So I have 24 to 40. What can I divide these both by? We could divide by 2. What else could we divide by? Can't divide by 10. We could divide by 4. What else could we divide by? 8. What's 24 divided by 8? 3, 5, 3/5. So for every 3 hours that she works at the library, she works for a total of 5 hours. Total. The table to the left shows the number of miles Joe ran, walked, and cycled. Give the ratio of number of miles he ran to the total number of miles. We have to add these up. So this is 20, 3, 4, 5, 50. How many miles did he run? 15. We just added his total miles to get 50. What can we divide these both by? By 5. So we have 3 over what? 10. So for every 3 miles he moved, he was active for a total of 10 miles. Yes. In the last game, the Packers scored 4 less than twice the number of points that the Seahawks scored. All right, so we have to say twice this minus 4. What's 16 times 2? 32, right? 32 minus 4 is 28. So write a ratio for the number of points scored by the Seahawks. So the Seahawks scored 16 to the number of points scored by the Packers, which we just found to be 28. What can I divide these both by? Where do you see? Good. 4. If you weren't sure, you could start by 2 and then divide by 2 again. This is 4 and this is 7. So for every 4 points that the Seahawks scored, the Packers scored 7. A jar contains 13 pennies, 9 nickels, 10 dimes, and 8 quarters. What is the ratio of coins worth at least 10 cents to the total number of coins? So these 2 are both worth at least 10 cents, right? So we have 18 in total. And how many total coins? 18 plus 9 is 27. 27 plus that 3 would be 30, plus another 10 is 40. Guys, there's an awful lot of side conversations, and I'm unsure why. I guess you're ready to go on and finish the next page on your own. You should be at this point. What can I divide both of these by? They're both even, so let's start there. So this becomes 9 and 20. I don't think they have any common factors. A bag contains 20 slips of paper. What is the ratio of prime? Oh, this is ridiculous. We're not worrying about that. All right. So you have lots of practice here. You have the remainder of the hour to get as much done of this as you can. So try to finish. If not, we'll have some days where we go back and finish with work completion. So be sure you are working on page 3. This is page 3. You're practicing. Remember, you're trying to simplify the ratios. Oh, I'm sorry. You've already done Alex today.
No, I haven't. I've done this today.
Oh, I'm sorry. You weren't here on Friday.